So particle A is 2.5 kg, so this is 2.5 kg, so write that down. And then particle B, which is 5 kg, and cos alpha is 0.8, so 0.8 is 4 over 5, so sine alpha should be 4 over 5, means it's 3 over 5, yeah, okay, which is 0.6. Okay, so if you have all this information, I can find out easily. Okay, so write down all the information that we have. Okay, now first calculate the acceleration of the system immediately after the particles are released. So to do that, so you have t. Okay, read the question, guys, because I've already read. So read the question, then you should be able to understand. So you have a friction that's acting opposite the motion. Okay, so since it's acting opposite the motion, so you need to subtract that. Okay, particle A is placed at rest, inclined plane B hanging freely. The two particles of pulley and the string lies in the vertical plane, the line of the greatest. Okay, so calculate the acceleration of the system immediately when the particles are released. Okay, now T minus m1g, m1 I'm talking about this, and m2 I'm talking about B. So m1g sine theta, or sorry, sine alpha over here. Okay, and then minus 12 Newton, and this should give you m1a. Okay, so inclined plane, so it's moving. The moment it released, B will go down, so it's going to pull A together. Okay, remember, so it's going to pull A together. So T minus 2.5 times 10 times 0.6, which is sine alpha, and then minus 12, this is equal to 2.5a. So T minus 27 equals to 2.5a. And what's happening at B? Okay, at B we have mg or m2g minus t equal to m2a. So m2 over here is 50. Okay, sorry, 5 kg times by 10, which is 50, minus t equals to 5a. So this is equation 2. This is equation 1. So solve 1 and 2. When you do that, you get t minus 27 equals to 2.5a. 50 minus t equals to 5a. So from here you get 23 equals to 7.5a. A equals to 3.067 meter per second squared. Okay, so from there I can find what is t. So 15 minus t equals to 5a. So t, I did this earlier, so t equals to 34.67 Newton. Okay, this is for part A. Okay, so for part B, okay, for part B, it's not C, it's part B. Calculate the total distance A moves up 2 seconds after the release. While the particles are moving, the string breaks. Calculate the total distance A moves up the plane from the instant since the particles were released, assuming that A does not reach the pulley. Okay, does not reach the pulley. So part B, let's continue here. So for part B, we have a plane, okay, which is moving. The moment the string snaps, it will move to a certain distance, but it didn't reach the pulley. It didn't reach the pulley. It will move to a certain distance, and then it will stop, and then it will slide down. Okay, it will slide down. So what is the distance that it has reached? Okay, that's what we gotta find. Okay, so to do that, subtract. Why we need subtract? Because I want to find what is the distance that it has traveled. Okay, so to find the distance, um, okay, distance that it has traveled initially will be s equals to ut plus half a t squared. Okay, that's the question. They have given us 2 seconds after the release only. So up to 2 seconds, let's find out what is the distance that it has traveled up to 2 seconds. So initially it was 0, 2 seconds after plus half, and the acceleration we already got that, which is 3.067. Okay, sub that. So 3.067 times 2 square, and the answer is 6.134 meter. So before the string snaps, it has already moved 6 meters. Okay, quite a distance that it has moved. So what was the speed that it was traveling? So v square equals to u square plus 2as. So v equals to square root of that. Initially it was 0. It started at rest. 2 times by a, which is 3.067, times by the distance, which is 6.134 meter. And if you square with this, you get the same answer, which is 6.134 meter per second. Okay, so it moved 6.134 meter, and the velocity is also 6.134. Now, what happened when the string breaks? Okay, when the string breaks, there's no tension. Okay, the moment string breaks, there's no tension. So we have to find what is the new acceleration. Okay, so F minus mg sine theta minus 12 equals to ma. So string breaks, F or T equals 0. So this will be 0 minus mg, which is 2.5 times 10 times by 0.6 minus 12 equals to 2.58. Okay, so from here we know that's 25 times 0.6 minus 12 equals to 2.5a. So a equals to negative 27 over 2.5, and the answer is negative 10.8 meter per second square. So it was decelerating at this speed. Okay, negative 10.8. Okay, this is deceleration. Okay, so to find the distance it's traveled, okay, after it has snapped, okay, or string breaks, okay, how far the distance goes. To do that, we use v square equals to u square plus 2as. When it moves, it's going to end slowly. Okay, this velocity will decrease. Okay, acceleration because of deceleration, and it will stop. So when it stops, u equals 0. Sorry, v equals 0. U is the initial velocity that it was already traveling in 2 seconds, which was 6.134. We already got that. Okay, you guys can look at it later. And then plus 2 times by negative 10.8, because this is our new acceleration, times by s. Okay, so from here we get negative 37.6259 equals to negative 21.6 s. So from there, s equals to 1.742 meter. So basically it has traveled another 1.742 meter before it stops. So this is the distance that it traveled during deceleration. So total distance equal to 6.134 plus 1.742, and the answer is 7.876 meter. So it has traveled, before the string breaks, it traveled 6 meters, okay, 6.13 meters, and then after string broke, the moment string breaks, it has traveled another 1.742 until it stops. Okay, so altogether 7.876.